Hello viewers, I am Princy Joy from Department of Computer Science, Teresian College, Mysore. Today we will discuss about quicksort technique. As we all know, sorting is a method of arranging the items either in ascending or descending order. There are different techniques to sort the element in an array. The most popular sorting techniques are quicksort, merge sort, bubble sort, selection sort and insertion sort. In today's session, we will discuss about quicksort. In this sorting technique, we are using divide and conquer method. In quicksort, we will be dividing the given array based on pivot element. Before we start our quicksort, we have to remember some rules. The first rule is, if a of I is less than or equal to pivot, we have to increment I. The second rule is, if a of j greater than pivot, we have to decrement j. The third rule is, if I less than or equal to j, we have to swap a of I and a of j. The fourth rule is, if I greater than j, swap a of j and pivot. Here, when the first rule becomes false, then only we have to go to the second rule. Same way, when the second rule goes wrong, we have to go to third rule. When the third rule goes wrong, we have to check the fourth rule. In any step after swapping, we have to start from the first rule. Now we will start our quicksort with an example. Here we can see the given array is 5, 1, 3, 9, 6. The positions we can see just above the numbers that are nothing but 1, 2, 3, 4, 5. Here I and j are the starting and ending position, and the pivot element p always pointing to the first element as soon as we start the quicksort. According to that, the pivot element is 5 and the position of I is 1 and the position of j is 5. Now we will start our quicksort according to the rule. First we have to check whether a of I is less than or equal to p. Here a of I is 5, p is also 5. So the condition is true. We have to increment I from first position to second position. After incrementing I from first position to second position, again we have to check the first rule whether a of I is less than or equal to p. Here 1 is less than 5, so the condition is true. We have to increment I from second position to third position. After incrementing I from second position to third position, again we have to check whether a of I is less than or equal to p. Here 3 is less than 5, so the condition is true. We have to increment I from third position to fourth position. After incrementing I from third position to fourth position, again we are checking whether a of I is less than or equal to p. Here 9 is not less than 5, so the condition is false. Once the first condition becomes false, we have to go to the second condition, that is whether a of j is greater than p. Here 6 is greater than 5, so the condition is true. We have to decrement j. So the j is decrementing from 5th position to 4th position. After decrementing j, again we have to check whether a of j is greater than p. Here 9 is greater than 5, so the condition is true. We have to decrement j from 4th position to 3rd position. After decrementing j from 4th position to 3rd position, we have to check whether a of j is greater than p. Here 3 is not greater than 5. The condition is false. Once the second condition becomes false, we have to check the third condition whether I is less than or equal to j. Here 4 is not less than or equal to 3, so the condition is false. Therefore, we have to check the fourth condition, that is whether I is greater than j. Here 4 is greater than 3, the condition is true. If I is greater than j, we have to swap the pivot element p and a of j. So we are swapping 5 and 3 in the given array. After swapping, we can see the pivot element 5 reached in its correct position. To confirm that, we have to check the left subarray and right subarray. Here, the left subarray elements 3 and 1 are less than the pivot element 5, and the right subarray elements 9 and 6 are greater than the pivot element 5. Here the given array is divided into left subarray and right subarray. After dividing, apply the same rules what we have discussed earlier for both left subarray and right subarray separately. Consider the left subarray 3 and 1. Here the pivot element p is 3, position I is equal to 1 and j is equal to 2. Then we have to check the first rule whether a of I is less than or equal to p. Here 3 is equal to 3, therefore the condition is true. We have to increment I from first position to second position. After incrementing, again check the first rule whether a of I is less than or equal to p. Here 1 is less than 3, the condition is true, so we have to increment I value from its current position. After incrementation, the value of I is 3 and the value of j is 2. Here we can see I became greater than j. According to fourth rule, if I is greater than j, we have to swap the pivot element p and a of j. So we are swapping 3 and 1 respectively. After swapping, we can see the given left subarray 3 and 1 became 1 and 3. And the pivot element 3 is reached in its correct position. Next, consider right subarray 9 and 6. Here the pivot element p is 9 and position I is equal to 1 and j is equal to 2. Then we have to check the first rule whether a of I is less than or equal to p. Here 9 is equal to 9, so the condition is true. We have to increment I value from first position to second position. After incrementing, again check the first rule whether a of I is less than or equal to p. Here 6 is less than 9, condition is true, so we have to increment the I value from its current position. After incrementation, the value of I is 3 and the value of j is 2. Here we can see I is greater than j. So according to fourth rule, if I is greater than j, swap pivot element p and a of j. So we are swapping 9 and 6. After swapping, we can see the right subarray 9 and 6 became 6 and 9. The pivot element 9 reached in its correct position. Now we have to combine the left subarray, pivot element and right subarray. And we will get the resultant array, that is 1, 3, 5, 6, 9. Now the given array is sorted. Thanks for watching.